We're going to look at a couple more problems of solving for all solutions, but this time it's not going to work to just be able to isolate the trig function or to combine like terms in order to isolate it, so we're going to have to try something else. In this first example, it looks similar to this, where if you see both terms, there's something that's in both of them, and we can factor out a greatest common factor, and then we can write what's left in each term. Similarly here, if you underline both terms, there's a sine of x that we can factor out, and then we're just left with a 1. Sine x times 1 is sine x, plus sine x times tangent x is sine x tangent x. Now, just like we would down here, you could set each factor equal to 0 to solve for x. That's what we're going to do up here. Sine of x equals 0, and 1 plus tangent of x equals 0. Sine of x equals 0, we need y to be 0, that's here and here, so that's 0 and pi, but we're solving for all solutions, so 0 plus 2 pi n and pi plus 2 pi n, or a better way of writing that would just be 0 plus pi n, because instead of saying 0 plus 2 pi a bunch of times, getting that same thing, and pi plus 2 pi a bunch of times, we can shorten that and say 0 plus pi. And you'll hit all the spots that you need to. And 0 plus pi n is the same as pi n. So this would be your best answer, but this still gives you the right answer as well. The next example looks similar to this, where we can factor it. X minus 5, x minus 1. Remember, two numbers that multiply to the 5 and add to the negative 6. Here it's similar. We have a sine of x squared minus 6 sine x plus 5. If you want to write your sine of x's in parentheses, it might help you to see how similar it is to this. Instead of x squared minus 6x plus 5, we have sine x squared minus 6 sine x plus 5. The sine x's have replaced the x's. When we factor it, it's going to be the same as this, but instead of those x's, it's going to be sine of x minus 5 and sine of x minus 1. Now we can set both factors equal to 0 to solve. Sine of x equals 5, we're looking for an angle where y is 5. If you think of the unit circle, the highest y value we get is 1. Or if you think of a sine graph, the highest you're going to get is 1. So this won't give us any solutions. Sine of x equals 1, an angle where y is 1. It's only this one, that's negative 1, so it's not down there, just here, which is pi over 2. And we're looking at all solutions, so plus 2 pi n. So when you're solving for these, I would first try to see if you can combine like terms like we did in the first video, but if that doesn't work, then I would try to see if there's anything you can factor, whether it's a greatest common factor or factoring a trinomial like the problem we just did.